Section 4.5, Combining Probability and Counting Techniques. This section is really all about combining what we learned in sections 4.1 through 4.4. So we're going to look at counting problems that have more complicated solutions. A helpful trick for these problems is to look for certain key terms, and the key terms are important because they define the method to be used to find the correct answer. So we have at least n or no less than n. We know that x is going to be greater than or equal to n. At most n or no more than n, we're looking for values of x that are less than or equal to n. Greater than n means x is greater than n, and less than n means x is less than n. Between n and m means that n is less than x is less than m. Or is a probability question where we're asked to find the sum of probabilities and subtract the intersection. And an AND question is where we're asked to multiply probabilities in a multi-stage event. Let's read through our first example together. We have a group of 12 tourists visiting London, so that means n is equal to 12. At one museum, a discounted admission is given to groups of at least 10. So keyword at least means 10 or more. How many combinations, so note it's telling me that this is a combination, of tourists can be made for the museum visit so that the group receives the discounted rate? I've set this up the same way your unit projects are set up, so that the input and output columns are set to either display the input or the computation. So in this case, we know that I need a group of 10 or more. So that means combin, I have 12 items, and I can have 10 people visit the museum, or I can have out of 12, 11 people visit the museum, or out of 12, all 12 can visit the museum. So 12, choose 12. Now, in order to show that as an output, I'm just going to click on that cell and notice the formula that I'm using is in the formula bar. I'm going to copy that. I'm going to go to the output cell, back to the formula bar, and then paste that. And that is going to give me the computation. So there are 79 different combinations of tourists that can be made for the museum visit so that the group receives the discounted rate. Let's take a look at examples 2 and 3. In example 2, Jack is setting a password on his computer. He is told that his password must contain at least 3, but no more than 5 characters. So that tells me 3, 4, or 5 characters. He may use letters, so there are 26 letters in the English alphabet, or numbers 0 through 9, so a total of 10 options. How many different possibilities are there for his password if each character can only be used once? So we're first going to look at passwords that contain 3 characters. We know that in a password, the order of the characters does make a difference. So this is a permute question, and there are 26 letters and 10 digits, so a total of 36 options I can choose from, and I'm going to choose 3. So that value would be the total number of 3-character passwords. But I can also have a 4-character password. So I can take 36, choose 4, or no more than 5, so that includes 5. So permute 36, choose 5. So again, I'm going to just grab that, come over to the output, and paste. And that is the total number of passwords in 3 through 5 characters. Now, example 3 is related to that. It says, suppose Jack's computer randomly sets his password using all of the restrictions given. What is the probability that this password is an arrangement of the letters in his name? Well, it's a probability, so we already know that the denominator of our fraction is going to be our previous output. This is the total number of ways. So now we need to think about how many ways could we have Jack's name in any order. So again, because it's in any order, J-A-C-K or C-A-J-K and so forth, this is going to be a permutation. So I have 4 letters, J, A, C, and K, and I have to choose all 4 of them. And I'm going to divide that by the output. Again, I'm going to copy this, And then I'm going to paste it over here. And notice the number that it gives me, which is a very small number. So if you're not sure what this -7 means, it means if I take the decimal from where it is right now, I'm going to go 7 digits this way. So it's 0.000005 139 and so forth. So it's much smaller than 1, very, very close to a probability of 0. Let's take a look at our final 3 examples. An elementary school principal is putting together a committee of 6 teachers to head up the spring festival. There are 8 first grade, 9 second grade, and 7 third grade teachers at the school. In how many ways can the committee be formed? So we know that there are going to be 6 teachers, and we're looking for the total number of ways that this can be formed. So this is going to be, because it's a committee, it's going to be a combination. And the first value is all of the teachers. So 8 plus 9 plus 7, which you can either add yourself or do just as I did. How many are we going to choose? We're going to choose 6 of them. So that's going to give me the total number of ways the committee can be formed. That output is equal to 134,596. Next, in how many ways can the committee be formed if there must be 2 teachers chosen from each grade? Okay, so again, this is going to be a combination, but I need 2 from the 8 first grade teachers, so 8 choose 2, plus 2 from the 9 second grade teachers, so 9 choose 2, plus 2 from the 7 third grade teachers, combin 7, 2. And again, I'm just going to take that input and paste it in my output cell, and I get 85. Lastly, if the committee is chosen at random and with no restrictions, so that's this number right here, at random with no restrictions, what's the probability? Okay, now probability means we're going to be dividing, that 2 teachers from each grade are represented. Well, we know that there are 85 ways for 2 teachers from each grade to be represented, and the total number of options is 134,596. So we're just going to take K11 divided by K7. And again, we're just going to copy and paste into the output. And we find 0.0006, or about 0.06%.